Okay. So basically today we are going to talk about asynchronous programming, and just a brief recap of what we saw last week on Thursday. Okay. So we started saying that JavaScript is single-threaded, so it's very important that we learn how to program in an asynchronous way. Okay. And we saw some examples, like you know, the simplest one is a set timeout that basically sets a function to be executed later in time. Okay, and we saw how the system works, because there's this event loop. Okay, that when nothing needs to be executed synchronously in the JavaScript call stack, simply looks for the callback queue. Okay, and if something needs to be executed, it's taken inside the call stack, it's called and executed. Okay, that's the basic way in which Node.js, but also the browser, especially the browser, works. Okay, it's basically an event-based system. Okay, and so we can write asynchronous callbacks. It means functions. Callback means function, as a normal standard function in JavaScript. It's just the way in which it's used that makes it asynchronous, because it's called whenever the system wants to call it. Okay, and well, yeah, we saw how to handle errors in callbacks, and we saw an example with the database. Okay, and we chose SQLite as a database. That's the one that we require you to use for the exam, because it's very simple. Okay, we don't need anything really complex, and it's easy to handle in a submission of a project where you basically submit files. Okay, because the database is a single file. We saw how to use it, and we saw that we need to pass callbacks that will be executed later by the system asynchronously. Okay, upon completion of the operation, like the select, so for querying data, other ways of doing the select, and run for other type of queries, insert, delete, update. Okay, okay, that's this small thing. I mean, we need to be careful because something is returned in the this object. You remember what we discussed about the this object, and we cannot pass an arrow function here because how the this works in JavaScript. Okay, and use parametric queries. We will go back to this point later in the course. Okay, always use parametric queries. So don't construct a string yourselves when something coming outside of the SQL query is involved. Okay. Okay, and we saw examples, right? So okay, this very basic example, but I mean that's the point that interested us a lot. So I mean, things are executed asynchronously, right? So we cannot simply print stuff at a certain point assuming that the asynchronous operation has been finished. Okay, we tried this example, and with the empty array it printed the empty array. Okay, because when you call the dball, you pass a callback, and you need to wait for the callback to be called. And the callback cannot be called in any case until you finish the execution of the synchronous code, that is this piece of code, until the end. Okay? So this prints an empty array. And so how do we solve the problem? Well, actually there's no simple way to solve the problem. Well, today we will see one way, okay, but I mean it's a quite complex, and it will require basically the whole lecture for solving it. Okay, and this problem becomes even more complex when more than one asynchronous operation is involved. Like here, there's a for 100 operations. Actually, 100 plus 100, insert plus select that counts the elements and so on. Okay, and we saw last time things are not getting executed synchronously. I mean, not in order. Okay, and that's what we get. For instance, I mean, you can get something different. And so, how do we force waiting for the execution of the callback? Well, the answer is, in a certain sense, simple in the sense that we just write the code that need to be executed later inside the callback. But I mean, it's simple but not practical, because like in this example, you should write one thing inside the other. Okay, one piece of code inside one callback, but that callback has to be inserted in another one, and so on. Okay, and so that led us to this concept of the promises. Okay, and so if you want to perform multiple asynchronous actions in a row using callbacks, you should write the code inside the callbacks. Okay, that means that for sequential code that execute asynchronous operation, it starts to become a bit messy. I mean, it's nested, or even worse, like before, it's even more complex to handle, because you need to handle, I mean, you need to restructure the code. Okay, we can try this code just, you know, as a practice. I put this code online on the usual website. So you go to the Polito WA-2025, so the course and lecture examples, week number 3. And then there's this readline slides. Okay, so you already have it in case you want to try it. Okay, just copy and paste from the slides. Okay, so let's try it. Code. We open Visual Studio Code, as you should be able. I mean, I hope in last week in the labs you all came, and at least you are all able to use the Visual Studio Code. If not, please come to this week's lab, okay, and we will fix it. So you can start working on JavaScript, okay? And so this is the readline slide that you saw before. Oops, too big. Okay. And so how do we use it? Well, as usual, I mean, we enter the directory and the readline slides, okay? And we just execute it, node readline slides. We are lucky in the sense that we require a package readline, but it's already included in Node for this time. I mean, recent versions of Node included it in the distribution. Okay, so we don't have to install it for this. For few packages, I mean, we just need to say the environment we would like to use them, but we don't need to install them. Okay, so that's why it works directly, just as a single file. And it collects some information. You see this error question. Basically, you pass a callback, which is actually all the rest of the code, because the rest of the questions are inside. Okay, because I want to execute the rest of the questions afterwards, right? And when I give an answer, okay, I type something, I don't know, lecturing, okay. I press the enter, and so the callback return is called. So we can say the function returns, but I mean, there's no function that returns. I mean, it's a new function that is called, which is actually the callback, the one that is highlighted here. And so it gets executed, so it goes on the call stack, it gets executed, and it makes another call, question, okay, with this parameter and another callback, the one inside. And again, there's nothing else to do, because the code is terminated here, okay? So basically now the call stack is empty. We are waiting for something to be put in the callback queue and to be put in the call stack and executed. And until I give an answer to this question, nothing will be executed, okay? So nothing will be put in the callback queue first. So let's say, of course, it's important, yes, okay? And now this callback is executed because it's been put in the callback queue. As the call stack was empty, and the event loop has put it in the call stack and executed it. And so this leads, oh no, this one, right? Which one is it? Yeah, this one was executed, okay. Is the task private? No, okay. And so this one will be executed, okay. So just no, okay. task deadline. That's the last one. Okay. Today. Okay. And then the code ends because the last callback is executed and there's nothing else to do. Okay. So you close you call the close method on this object that closes the input-output channel. Okay, but that's depend on the library. Okay, so that's the way this system works. But as you see, every callback adds a level of nesting, so it's inconvenient, right? And when you have a lot of callback, the code starts to be complicated very quickly. So this leads to this so-called callback hell. Okay, so it's messy code in short. Okay, and so who designed JavaScript? I mean, who evolved JavaScript actually, because they were not included since the beginning, but at a certain point they were included. The designer of JavaScript implemented this feature of the language, which is called promise. Okay, that basically is meant to simplify asynchronous programming. Okay. Actually, yeah, it's also a fundamental building block for newer types of functions that are introduced by two new keywords, async and await, that we will see today. Okay, but this is ES 2017. That means ES8. So more recent versions of JavaScript. But as we said in the beginning of the course, we just don't care. I mean, what we use here supports this keywords and this system very well. Okay, so we can just use it. What is a promise? Well, the promise is an object representing the eventual completion or failure of an asynchronous operation. So we ask the system to do an asynchronous operation, and there will be a result that basically it's the result of the operation that we asked to perform, like reading in the database, like reading from the keyboard, and so reading a file, and so on. Okay, waiting for the answer from a server. That is our most common case later in the course, and so on. And so, as we said before, we need to handle the situation in which there have been errors. Okay, so there's been a failure of the operation, or the operation was successful and we need to get some value in return. Okay, so the result of the operation, like we read from the database, and we want to have the data. Okay, and so in short, to avoid nesting functions, it's better that we make functions return this object, this special object, that is a promise that is able to supply the value of the result of the operation at a certain point in the future. Okay, instead of immediately trying to return the final value, which is not available because it's an asynchronous operation. The operation has yet to be performed. Okay, and so in short, I say promises standardize a way to handle both errors and return a value. Okay. And for the errors also, they are a way to propagate the error correctly to a chain of promises, because the most difficult thing, and this is more or less common to all languages, is handling errors, right? That's why exceptions have been introduced in some languages and so on. It's basically to handle errors, which is a difficult thing because you need to take care of all the cases, make sure you don't forget any case. Okay. And of course of return values, but that you're typically more interested in the return value, so it's very unlikely you forget to handle the return value. Promises. So these objects can be both created or consumed. So there's somebody that creates the promise. Okay, so you execute an asynchronous function. The function will create the promise. And then at a certain point in your code, the value stored in this promise and the status, success or failure, will be consumed by some other part of the code, okay, to read the result in short. And they are really important to use. I mean, you cannot just say, well, I like writing nested callbacks, and that's all. Because many web APIs expose promises to be consumed. In the browser, we will use a primitive, so a function that will return a promise. That is the fetch function that we will see later in the course. And this, in modern browsers, I mean, in all browsers, returns a promise. Okay? It has been designed in this way. So we need to be able to use the promises correctly. So when a promise is created, it's just an object, and we don't know how things will develop over time, if the operation will lead to success or failure. At a certain point, a promise let's say the status is determined, the final status, and we can consume a promise. Okay, and so the function that calls the asynchronous function, it continues the execution. It just gets an handle to the reference. I mean, a reference to this promise object. Okay, and when the promise will be solved, that means it will have a final status. So it will be fulfilled or rejected, as we will say. So it's success or failure. We will call some other call that is actually what before we wrote as callback to handle the value that is the result of the asynchronous operation. Okay, so in short, the caller function will wait for the promise to either return the promise in a fulfilled or rejected state. Those are the two states in which the promise can end. Okay, if the operation has been successful or if there has been a failure. Okay, so let's have a look at an example. It's difficult to talk in theory about things, especially when they are so practical, right? So promise is an object, a JavaScript object. You can create it as any other JavaScript object, typically with the syntax new promise. Okay, promise is a function. It can be called as a constructor function because they designed it in this way. This constructor takes an executor function, so this from the start of the parenthesis to the end. Okay, that's the parameter of the constructor of the promise, which is a function itself, which as parameters it takes other two functions. Okay, so this executor function, this resolve reject called, takes two functions as parameters that for convenience we call them resolve and reject. Okay, of course these are just parameters. We can call them as we like. They are just parameters of a function, but just for clarity, if you write resolve and reject, you remember what they do. And the promise, once it will be resolved, will call either resolve or reject, not both of them. Okay, just one or the other. Okay, if the asynchronous task completes successfully the operations, it will call the resolve with some parameter typically, that is the return value of the promise. Remember, this is JavaScript. It can be any kind of parameter, so it can be number, a string, but also reference to an array, an object, and so on. Okay, and reject if there is a problem. Okay, if the task fails, and typically you pass some information to determine which error has happened, like a string or maybe an object containing strings and other information useful to debug or to print the error. Okay, so that's basically the code. Okay, of course this code is useless because I mean you cannot both call resolve or reject. We need to see a more practical example like this. Okay, so return new promise resolve reject. Okay, where let's say we call reject in case there's some parameters, some variables that we use to perform the operation that has an invalid value. Okay, we cannot execute the asynchronous operation. Or we call the resolve when we have executed the asynchronous operation. In this case, there's nothing that we like to do except waiting. Okay? So in short, at the beginning, at the creation of the promise, we call the set timeout and we give the resolve function to call. Okay? When a certain amount of time has passed. Okay? And so the promise will have a final value after some time, depending on which was the value of this variable, duration. Okay? Oops, sorry. Duration that we passed in the beginning. Okay? Just to be clear, I mean, how this code works. I mean, this code is full of closures. You remember the closures? Actually, we don't really need to understand how closures work. I mean, this is just a matter of visibility of the variables, right? But you know, these functions inside make a closure on duration. Okay, when you pass, when you call the set timeout is a closure on resolve, and so on. Okay, they are just variables. They remains visible to the inside function. Okay. So what does this function do? Well, basically it returns a promise in which if duration is 0 or greater, it will call resolve after a certain amount of time, depending on the duration, which is passed here, so in milliseconds. And if we pass a negative value, it will simply immediately reject the promise, to make the promise become have a final value which is rejected. So the promise will do nothing. It will be immediately solved, and we will pass an error, okay, an object error to the reject, just to give it back to the caller, okay, so the one that create the promise. There was a question, right?
For instance,
yes.
Lots of function in the call stack.
Mm-hmm.
They have the set timeout with a small duration.
Yes.
How can I deal with the fact that, for instance, I have to complete all the function in the call stack before calling on a synchronous function?
No, I mean, so the question for who is listening is, you know, there are many functions in the call stack, right? And synchronous functions. So they need to be executed until the end. Okay. Yeah. And then we have, let's say, the resolve or whatever other function that is put in the callback queue, right? Well, nothing to do. I mean, we will wait for the end of the execution of the synchronous function. So indeed, this duration, actually, it's a minimum duration time. Okay, so it doesn't guarantee you that, let's say, after 1 second, if you pass 1000, after 1 second, the function is executed. Because if the call stack is busy, nothing we can do about that.
So
okay?
Sorry?
It's
a best effort.
yeah. Let's say it's sort of best effort approach in terms of scheduling things. Yes. I mean, the only guarantee is that it will not be called before 1 second. Okay? And that is also why we say that a certain time, here in the previous, yeah, yeah, try not to write a blocking code, okay? Yeah. So if you write a blocking code, it means it takes time to be executed. That means that we run into the problem that your colleague said. I mean, the call stack is busy. Everybody will have to wait, okay? And if there is something important that is waiting, like the response to a user interaction, everything seems to be blocked, so freezed. You click and nothing happens, okay? So that's a really important point to highlight, right? So just to remind you, you know, that's the situation, right? If something is here in the call stack, nothing can be executed here from the callback queue. Even if we say set timeout, set whatever, they will wait, okay? Okay. So, Okay, so what did we do here? Well, basically we created a function that only did one thing, just return, right? A new object, which is actually a promise that has this specific behavior. So when we call the function wait promise with a certain time, like 1000, so for 1 second, it will create a promise. And the promise will immediately reject if we pass a parameter less than 0, or it will call the resolve of the promise. So the promise will be solved after at least 1 second. Okay? So that's what we wrote. And how do we use the promise? That's the missing part, right? So we saw how to create it. How do we use the promise? How do we consume the promise? That's a technical term. Well, when the promise is either fulfilled or rejected, so the operation has been successful or not, so we called either the reject or resolve, we can attach callbacks to the promise to be executed at that point. Okay? How do we attach the callbacks? Well, each promise object has a certain number of properties, and actually these are methods because you can call them. Okay, so it has at least 2 methods, the .then and the .catch. So the wait promise, the return value is the promise, and you can call on this .then or .catch. And you see that you pass to the .then or the .catch another callback. That's actually the callback that you want to execute once the promise is fulfilled or rejected. So if once the asynchronous operation ends with a success or a failure. Okay. So when you call here, you call the resolve. What is written inside the then will be executed. So executed means will be put on the callback queue, waiting to be executed. Okay, and the same for rejected. So what you put inside the catch will be put in the callback queue if you call reject here in the promise. Okay, so here is the code is very simple, right? We take a parameter and we do console log of the parameter, so just to try things. Okay, actually, then and catch are instance methods defined by the promise object, and well, you can omit the .catch, but also I think it's next slide, right? All methods return promises too, so you can chain the calls: then, .catch, .then, another .then, .catch, and so on, because each .then, .catch will return another promise. Because so you have another method, .then, .catch, to attach a new callback. Okay, so that's why we can write .then, open the round bracket, close it here, and .catch here. Yes, that's a question.
The chaining of the then catch.
Yes.
Are they will be called like on the same time at the same time?
No, they will not be called at the same time. I mean, each one returns a promise, so you need to execute the previous.
The first one.
I mean, the first one, yes, the .then will return a promise, okay, which is not being solved yet, so we don't know if it's fulfilled or rejected.
It has to be the same, like the same as the first promise.
No, it's another one. It will be created automatically by the .then, okay? So that's another one that will be solved when the previous one will be solved after calling what you pass to the .then. It has its own resolve and reject. The thing is that you don't control the resolve and reject except indirectly, I mean by passing the callback. So what you pass in the callback is what it will be executed when the promise is solved. Okay? So it's like you have a chain of promises, a chain of objects. Each one is attached to the next one. But at each step, you have a callback to execute when the promise is solved. And to solve the last one, you need to solve the previous one, and so on. And so the callbacks will be executed in order. I mean, put on the callback queue and then executed when there's time, okay? But they will be executed in order, and that's why you can, chain the callbacks and chain the operations with the promises in a simpler way. So just .then, 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 okay? So let's try to start with a simpler example where you just have one .then, okay? So wait promise, that is the previous function, okay? And of course here you don't pass anything, that will be undefined, and we need to check what the code does for undefined. But let's say, wait promise 1000 means 1 second, .then, and a callback that just print success, okay? Or a catch and console log error with the error that is something that has been passed here with the catch. What is passed here, error, and here, which is not available because we didn't specify a parameter, is what we use here in the reject, and well, here in the resolve, which is actually nothing because the set timeout passed nothing. We didn't put a third parameter, okay? I think we can try the example. Let me see if we have... no, we have the async await. I forgot to put this one. Async await. Yeah. Well, we have time. Let's try to build it. Okay, so it's something practical that we can try. Right, promise JS. Use a strict. Don't forget. Okay, we do a bit of cut and paste from the slides. Let's hope everything goes fine. So, just what has been written on the slide, right? Yet implemented. Okay. And we use it, right? So, but just try to use something that we put on the slide sometimes, so you see if you understood everything or not. Okay, let me format it a little bit better. Where's the place? Format selection. Okay, so we have a bit of nice indentation and so on. Okay, so we don't use external libraries, so we can just run the code, right? It should work, hopefully. Node, promise. You see, 1 second of delay and then success. Let's try again. Okay. What happens if I pass -1? So something different. So the duration is less than 0, and so the reject is called instead of the resolve. Well, let's try. Okay, there's some. Okay, that's the error. The error is printed in this way because actually we created, an object. Okay, error, and we just printed the content of the error. Otherwise, you can just, send back a string, and that's all. It's easier, maybe. Okay, let's try with the string. Okay, so we don't create this. I mean, error is a predefined object in JavaScript, just to help you throw things when there are errors. Okay. You see that this happens immediately, okay, because there's no set timeout involved. Okay. It doesn't mean that it gets executed immediately when you execute reject. I mean, this wait promise has to finish the execution. Here at the dot, a promise is returned. Then this callback is attached to the success of the promise. A new promise is returned. At this dot, with a catch, another callback is attached to the new promise in case of failure. Okay? Then the code ends, and we have a function to be executed in the callback queue, which is actually no, sorry, the first promise is rejected, okay? And then there's this function to, so this reject pass to the second promise, okay? This is a missing piece that we need to explain. And then this function will be executed. It will be put in the callback queue, and then there's nothing else to execute. It will be executed. So we will have console log and the content of the console log, error with the string. Okay? So we need to, yeah, that's a question, right? Is the order between then and catch important? Yes. I mean, depending if the promise is rejected, the original one, the one from which we start, okay? If we catch something, we cannot do .then afterwards in case there is something that we need to do with the then afterwards, okay? So we typically put the then before and the catch afterward, because after the catch, typically you don't want to do anything, okay? You could do the reverse. I mean, then and catch are just attached to resolve and reject. If you want to use them in the opposite way, you're free to do. I mean, but you mess with the code. I mean, you typically want to solve first the let's say the correct execution case and then the error case. That's because typically with the error case, you would like to stop processing the operations. And with the then, so with the correct execution, you often want to put the second operation and the third operation and the fourth operation in the chain. So you need to do the .then before, okay? Otherwise, you cannot chain one promise with the next one, okay? Because they are executed in order, depending on how you declare the .then, okay? There's still a missing piece. You need to return a value in each callback to make the value available to the next promise. But I mean, it's available to the next promise in the sense that in the order in which they are declared here, okay, in the .then order, okay. It's easier to use than to explain. I mean, so let's see. So we have the .then that we can call on a promise. And we can pass one callback, that is what we did in the example, that has to be executed when the promise is fulfilled. So everything went fine as we expected. No errors, okay? Just remember that callbacks are executed asynchronously. That means inserted in the callback queue and then by the event loop in the core stack whenever it's free. The callbacks will be executed when the promise is either fulfilled or rejected, okay? And if it's fulfilled, the one attached with the .then will be executed, and if it's not fulfilled, the one with the .catch will be executed, okay? So .catch, just take one parameter. I mean, just for your convenience, you could pass two parameters to the then. I mean, but it's probably not so clear. I mean, we are used to have the then and catch, like when you throw exceptions, you have a try except. Okay, and these are the equivalent of then catch. There is also a finally, similarly to exceptions, that is something that is executed in both cases. Okay, so after the promise is resolved, either with success or failure. It's like the finally in the try catch. In any case, you have something to do. Either you take the code on finally and you put it both in then and catch, or you just have a place like the finally where you put this code to be executed just at the end. Like you need to close the database, you need to close the file, whatever. Something that has to be done in any case. Okay? Okay, all these methods return promises too. They can be chained, and yeah, there's one important point to remember. It's that if you want a value to pass from one promise to the next one in the chain that you declare, you need to always return the result, okay, by the callback. So the callback has to have a return value, which looks a bit implicit here in this example, but you remember that arrow functions have an implicit return value. So this function returns the value of get issue repo. This one get owner issue owner ID and so on. Okay? If you are unsure, open the curly bracket and put return something. Okay? And then when you are sure, when you know what you are doing, you can shorten the code. Okay? This is really important. This is because these promises are chained. So when you attach with a .then a callback to another one, you return a new promise, and this promise is automatically attached to the previous one. And when the previous one is solved, the second one needs to be solved later. And it will take the value if the previous one has been solved and it has a value. Okay, either fulfilled or rejected. Okay. So all these methods return promises too, so they can be chained, as we saw, .then, .catch, or .then, and so on, and then .catch if you need it. And they are really, I would say, intuitive after you do some experiments, of course, as any other thing. So in one place you create the promise if it's your code. Otherwise, it could be somebody else's code, okay? Like, as I told you before, the fetch loads data from the network, is from the browser. It creates the promise itself, by itself, okay? And then when you need to use the promise, you just need to specify a callback for the case in which it's fulfilled, so success, and a promise for the case in which it's rejected, so in case there are errors. Okay? And you can get the value of the fulfilled or rejected promises just by taking a parameter from your callback. Okay? And use this parameter as you like. We printed it, but typically in the then, you pass to the next operation. Okay? As we saw before. In the catch, you're free to do what you think it's appropriate. Log the error, print it on the console if you are debugging, and so on. Okay? So like here, get repo info. Let's assume it's a function that returns a promise. You can do .then. So you can chain 3 operations. And you're sure that the second one, so what is specified here in the callback of the second one, will be executed only when the first one terminates. Okay? Because this promise returned by the .then will not be solved until this operation has been performed. Okay, so in short, we found a way to chain operations one after the other in a controlled way. Okay, even if they are asynchronous, but you see the code, it looks very clean because there's one operation, next line the other operation, and so on. You just need to be careful with the .then, and just as I told you before, always return the result of the previous operation to have it available for the second one, in case it's needed. But that's the typical case. You perform an operation, we want a value, and you use the second operation, and so on. So this repo, it is used to get the issue, and the get issue will return an issue, and it will be passed as a parameter to the second callback. And this issue will be used in some ways, and it will return an owner, and this owner will be passed as a parameter to the third callback. Okay? And at a certain point, you finish. I mean, there's nothing else to be done. That's okay. I mean, no problem. You finished doing the processing. Like, send an email. That's all. Okay? For this code, that's all. In case there are problems, basically all this then are skipped, but logically skipped. I mean, the callback will not be called anymore, and the promise will search for a dot catch and a callback attached to the dot catch to be executed. Okay? And so in case of errors, you will execute the callback with specified by the catch. Okay? And then, as we said before, at the end, after calling the catch or the then, you will call finally. I mean, the callback of the final will be called. Okay? Will be called means, again, it will be put on the callback queue. Okay, waiting for the execution. But if nothing else to do, it will be simply called. Okay. So basically, we solved the callback hell that we have seen before without having to nest operations. Now they are sequential operations, even though they are callbacks inside the then, but it's already something nicer to see, right, and to understand, hopefully. So a more complex example. Chaining, okay? This is more similar to what you are going to do for the exam at the end of the course, okay? The previous one was just, an example for the lecture. But let's say you need to use this API that I mentioned before, the fetch that is available in the browser to load an URL, where you load data from the network. And so you call this fetch, and I told you it returns a promise. So it means that we need to attach operations to the successful completion of the promise or to the failure of the promise. And in this case, we attach 3 operations sequentially to the fulfilled promise when there is success. So then status. A status is a function. JSON again, it's a function. And here data, well, actually this is a function, the whole function, right, on the whole row. Data and so on. And then catch error console log, just, to print something in case of errors. And as you see, this status is just a function. A function defined as an arrow function that takes a parameter, response, and it processes this parameter, response status is between 200, 300, and so on. And we can make it return a promise as well. Okay? Actually, I mean, if you return a promise, you already solved the problem of the next .then. Okay? That's already a promise. If you return a value, this value is simply passed as the value of fulfilled promise to the next .then, okay, in the chain. So here you can see also that you can return a promise which is already has a final value. You can create a promise already with a final value, with promise resolve or promise reject. Okay? Sometimes it can be useful. Okay? When you already know the value, I mean, there's no point in making set timeout or whatever. You can immediately create a promise with the final value. It's fine. No problem. Okay? The promise is just a container of a value and the status, fulfilled or rejected. Okay? Okay, status. And so the status will resolve or reject. It means we return a fulfilled or rejected promise. If it's a rejected promise, this JSON and data will not be called. Only the callback, the final callback with catch will be called. Okay. If we go here, promise resolve response, this promise will have a value response, and this response will be passed to the next callback, JSON, which takes a parameter that we again called response, just for convenience, okay, to see that they match. And we will return the value response.json. Okay? Remember, this is an arrow function. In the previous one, we opened the bracket, so we had to use the return keyword. Here, we didn't open any bracket, so the return value is the value of the expression response.json. Okay? Which actually you don't know, but there's JSON method on the response that comes from the fetch, okay, if you configured everything correctly, that returns a promise as well, okay. It's an asynchronous operation, it returns a promise, and it's fine because we are using it in the .then, and the next one is .then, so we will take the answer from this response JSON in case it doesn't give an error, so the promise is fulfilled and not rejected, and we take this data and we print the data. That's all, okay? In case there are errors, we will go to the catch, okay? We cannot try this code now because it uses this function which is just inside the browser, and we should also have a server that answers to a certain URL and so on, okay? But this is just, how to use the chaining principle for your purposes, okay? That's the question, right? Think.
Promise.resolve is just a way to make a promise already fulfilled.
Yes, exactly. Promise.resolve is just a way to make the promise already fulfilled. So it doesn't start in pending state, as we said in the beginning. It's already fulfilled. And the other one is already rejected. Okay? If we already know the value, and for some reason we want to have a promise, we can create it this way. Okay? Without making a new promise and so on, and only call the resolve and not the reject. Okay? It's like a static method of promise. Okay? Okay. Oh, no, I went back. So this mouse always wrong. Okay. Just a few more words about the promises. Well, promises are convenient because they allow us to represent the eventual return value of an asynchronous operation. And so we can make more, asking to perform more asynchronous operations at the same time, in parallel, or maybe in a race, so whoever arrives first, let's say, wins. And actually, there are static methods of the promise object to do these things. Okay? If you want to execute several asynchronous operations in parallel, you can do that. Promise all takes an array of promise objects as input, and it returns a promise as well. What's the property of the promise it returns? The promise it returns, it's only solved when all the promises have a final value, okay? Either fulfilled or rejected. So basically, promise all waits for all the promises that you pass. Like you need to load 3 things from the network, and you need to have all 3 things to go on in the processing, okay? You need to wait for all of them. You create 3 functions that returns 3 promises. You give them to promise all, and promise all will call all the 3 and will give you a single promise on which you can attach your callback, okay? Because otherwise you don't know where to attach your callback on the first one, second one, third one. You don't know which one ends first, okay? One option is execute the first one and then wait, execute the second one, and then wait and execute the third one. But if you want them to go in parallel, you need to have a way to, decide when all 3 are finished, are solved. Okay? And promise all is the answer. These are the technicalities in case you want to try, but it's better to read in the manual and maybe have a look at an example, which is easier. It will return an array of fulfillment values. It will tell you how the promise have been solved. You need to be able to process the results in some way. Okay? Promise race is a bit different in the sense that you give this race many promises, and once the first, one of them, any one, has been solved, it will return a solved promise, either fulfilled or rejected, depending on how the promise was solved. Okay? So where this can be useful, let's say you can download the same thing from multiple places. The first that arrives is fine. Okay? So you just have a race. Okay? A competition between different resources that need to be downloaded. the first you get is okay for you, and you don't care about the rest. They will be solved, but I mean, in your code you will not care. You just ignore the situation. Okay. So actually, last year, the previous year, I think we had some code about this, but I mean, this is just for completeness. It's probably not really required for the project, for your exam. I mean, for our simple projects, I mean, loading things one after the other instead of parallelizing things, it's okay. Okay? But, you know, for completeness, once you have the concept of the promise, you would like to parallelize things, well, you need to be able to, you know, find a way to make sure that all promises have been solved in a final state. And that's the way. Okay. So, are there any questions? No? Okay. Let me see. Yeah, we already saw the example. What can we do now? Maybe. Yeah. Well, let me introduce the next point, so you have time to reflect a little bit during the break, in case you want. Okay. So we have promises now. Okay. And you saw they are already a good step forward, and it says that you know, we can write things sequentially instead of nesting things, which is already a good thing for programming. Okay. But I mean, we can do better. Okay. And actually, JavaScript can do better because you know, the .then syntax is not so, you know, nice to write operation. We would like to have something like wait for this operation to complete and then proceed to the next line. Okay, so write code really sequentially. Okay, here we are doing something similar. I mean, we have a chain. If you got new line at the next then, we are sort of a chain, but we are still passing callbacks, right? So there's still this callback involved, which is not so, I mean, easy to think about. And so JavaScript developers, actually JavaScript maintainers, okay, the technical committee that maintains JavaScript, decided to introduce these two new keywords, async and await, which are really heavily based on the promises that we just saw before. Okay. So this ECMAScript 2017, so ES8, introduced the new keyword async and await. So basically, you can write promise-based asynchronous code that looks like synchronous code. So in short, we can prepend await when calling an asynchronous function, and we will make the calling code stop until the promise is resolved or rejected. Okay? So in short, we have this await keyword that can make the code stop. Okay? But the point is that we cannot just stop, you know, the code because you remember JavaScript is single-threaded. If you stop the code, you stop the execution of everything. Okay? So actually, you're not stopping the code. You're just saying we are waiting for the execution, the result of the execution of the asynchronous function that is written after await. Let me see. That's an example. Await resolve after 2 seconds. Okay? And so the code stops at that point, but it doesn't block everything. It gives the control to the event loop, which suspends the execution of the code, and it will take the next function in the callback function, and it will execute this next function. Okay? And then when the asynchronous operation is finished, so it has a final value, either the result or the error or whatever, it will put this continuation of the execution of the code in the callback queue, and when the stack is free, the execution will resume from the point of the await, after the await, okay? So from the result value and so on, okay? And to do this, actually, inside a JavaScript, the JavaScript environment, actually, the function returns a promise, okay? Has to return a promise, because I need to store the result of this asynchronous operation in some ways. And the way in which it does, it's using a promise, okay? And you don't have to write it, but you know what is executed after after solving the promise is the rest of the code after the await, okay? And you can take, in case everything is success, the result of the promise, and it will get assigned to the variable, left to the await, and the rest of the code will be executed. It's just a way to, to have a nicer syntax, but to do exactly the same thing that we are used to do with the promises, okay? And indeed, for everything, to make everything work, what you call is actually has to return a promise. And if does not return a promise, it will be made to return a promise. But if it's made to return a promise, it means that you didn't control when the promise is fulfilled or rejected. It's basically always fulfilled, and basically it doesn't help you, okay? It doesn't give you an error. That's good, but I mean, it doesn't help you because it doesn't handle errors and the termination of the operation, okay? So async and await are a way to avoid writing promises explicitly. But now, I mean, I would say after the break, okay, we will think about this async and await work in terms of promises that we just learned before, okay? So every time you make a function async, so basically you add the async keyword before declaring a function, you make the function implicitly return a promise, and every time you call await in your code, you assume that the function, the expression after await, returns a promise. And the stopping and resuming of the operation will be based on solving the promise that has been returned by the async function, has been waited for by the await keyword, okay? I know it sounds a bit confusing, and we will see an example after the break. But, try to think about the promises. We create a promise when there is synchronous operation, either ourselves or some function creates a promise, and we can catch the result. I mean, sorry, catch is a bad word. We can get the result through the then or the catch, depending if we want to get the result of the successful operation or the error, okay? And that's the basic way of using the promises. And then, since we don't like writing code like this, even though it's better than before with the nested code, we'll try to simplify things even more. So having this result value explicitly assigned to a variable, okay? Calling this function with the await, because we need to say wait for the execution of that function. That's the missing point, right? And if we don't have a keyword for the language to say wait for the execution of this asynchronous function, the code will continue as before, as we saw in the beginning of the lecture with the access to the database, right? We have the empty array, and we don't wait. If we don't wait for the DB-all, there's no point in printing the array, right? But if we can write something like await DB-all, everything is solved, right? But to make this await work, we need to think in terms of these promises, okay? And that's what implicitly JavaScript does inside the code, okay? Okay, I think you can think a little bit about this during the break. Okay, let's have a 15 minutes break in case you have questions about promises. You would like to try the example. I will commit the example now. It's just the slides, but I will commit it. Just come and ask me. Okay, there might be something that is interesting for all your colleagues, classmates as well, for after the break. Okay, no questions, so let's have 15 minutes break. Okay, thank you.